Hey guys, welcome to the channel. I'm going to be changing the name very shortly from Thinking Theology to the odds-on favorite right now is Trickle-Down Philosophy, because some folks get the idea that thinking theology means establishing theology or agreeing with it, and it's not. But they also make this idiotic comment or this idiotic perspective that theology doesn't involve thought. It does. It just happens to be thought that people disagree with. I'm agnostic. I'm just saying from a philosophical, contemplative standpoint, of course it involves thought. When Dawkins and Hitchens and other folks speak against theology, you have to be thinking theology in order to refute it. It doesn't mean you're agreeing with it. You're just understanding the concepts, precepts that are being put forth, and you're saying, I disagree with them for these reasons. Fair enough. Fundamentalists have their disagreements with science. It involves thinking about science. Very simple. Doesn't mean they agree with it. So from both standpoints. So anyway, I'm going to be looking at Sabine Hossenfelder's ideas. And this chick, she's just fascinating to me. I don't know why. It's one of these things. She's bright. She's quirky. And she's got a huge following. She's a physicist. Are dead people still alive according to physics? What a title. So we're going to look at this.
Okay, so let's talk about the physics of dead grandmothers. So I was sitting in a taxi together with a young man, and when I told him I am a physicist, he said, "Oh, can I ask you a question about quantum mechanics?" And so I thought, well, okay, go ahead. And he said, a shaman told me that my grandmother is still alive because of quantum mechanics. Is this right? I had to pause for a moment and try to understand. And after thinking about this for a while, I came to the conclusion it's not entirely wrong. But the thing is, it's got nothing to do with quantum mechanics. It's actually got something to do with Einstein's theory of special relativity. It's all about the reality of time. It's all about the question whether the present moment, this now which we experience ourselves, whether this is of fundamental importance. There are a lot of things, like those big existential questions about afterlife, that physics can actually tell us something about. My name is Sabine Hossenfelder. I'm a physicist and research fellow at the Frankfurt Institute for Advanced Studies. And I have a book that's called Existential Physics, A Scientist's Guide to Life's Biggest Questions.
Okay.
Before Einstein, time was this universal parameter. We all shared the same moment of time, the same moment of now that we could all agree on. But then Einstein came and he said, well, it's not that simple. And the major reason for this is that the speed of light is finite and nothing can go faster than the speed of light. It's the same for all observers. And this sounds like a really innocent assumption, but it has a truly fundamental consequence, which is fairly easy to understand, actually. If you ask yourself whether you know if the screen in front of you is actually there right now. Naively, we would say, yes, of course, it's there. I mean, I'm holding it in my hand or I see it directly in front of me. But we just learned that the speed of light is finite and nothing can go faster than the speed of light. So everything that you experience, everything that you see it as it was a tiny little amount of time in the past.
Ooh, I like this because I was listening to a seminar a few years ago. And it was on neuroscience and how the brain works. And our brains match things up to make them consistent. And one of the examples given was television. You're watching television and you see the mouths moving on the screen and you hear what they're saying, but those two signals are reaching your sensory receptors at different times. The sound travels at like a ballpark of 600 miles per hour. Light travels at 186,000 miles per second. So you are seeing their mouths move before you're hearing it. And yet your brain marries the two together, so it just looks like it's happening now or together. So that's a similar thing here where the speed, it seems like it is happening in the moment, but it's actually not. And then when you add the auditory component to it, that disconnect even makes the point easier to understand that light does affect how we see literally, and the time that it takes to get to us varies from medium to medium. All right, let's see where she goes with it.
So how do you know that anything exists right now? What do you even mean by now? So this is the problem that comes up in Einstein's theory of special relativity. And Einstein tried to construct a notion of now in this new theory, and he failed. So imagine you're looking straight ahead and there's a train going through to your line of sight, say from the left to the right. And on the train there's your friend, and let's call her Alice. Now, let's also imagine that at the exact moment that Alice, who's standing in the middle of the train, is looking straight at you, there are light flashes going off on both ends of the train. And the question is, did these light flashes happen at the same time? Now, if you want to answer this question looking at the train, that's pretty straightforward. There are those light flashes going off. They both come from sources that are the same distance from you. So of course you see them at the same time. But how does the same thing look from Alice's perspective? The light flashes go off, but while the light travels towards her, she's moving towards one of the light sources and away from the other. So the one path of the light is shorter and the other one is longer. So from Alice's perspective, the light flash from the front of the train arrives earlier than the one from the back. So she would say, no, they did not happen at the same time.
Nice breakdown.
And now the important point is that this is relativity. Neither of them is right and neither of them is wrong. They both have an equally valid perspective. And what do we conclude from this? Well, we conclude from this that there is no unambiguous notion to define what happens now. It depends on the observer. So they're both right. And if you follow this logic to its conclusion, then the outcome is that every moment could be now for someone. And that includes all moments in your past, and it also includes all moments in your future.
Is she going to pull a twist here where, just like when we see stars, we're seeing them as they were with our sun 8 minutes ago? I think the nearest star, Alpha Centauri or somewhere, that it's like 4 or 4.5 years away from us. And then like galaxies, we're seeing them as they were in the past. But is she going to say, eventually the light from Earth, including your grandmother, if you had a receptor acute enough that could pick it up or sensitive enough, eventually they're going to get the light from your grandmother. And so to them, your grandmother is still alive. But that's only a problem with the way in which they're describing it. Because we describe it, we're seeing things as they were in the past. We're just observing it now. So they would just be observing the grandmother. So what are the implications of how we even describe things? Let's see if she covers it.
So this impossibility to define one notion of now that we all agree on is called the relativity of simultaneity. And it's super important because it tells us that fundamentally this experience of now that we all share is meaningless. So the mathematical framework that Einstein came up with to make sense of this absence of now and the finiteness of the speed of light and the relativity of simultaneity is that he combined space with time to one common entity, which is called space-time. And more specifically, because the present moment has no fundamental significance, this entire space-time exists in the present moment, and it's become known as the block universe. In the block universe, the past, the present, and the future exist in the same way. There's just no way that you can single out one particular time as special. So the past in which your grandma is still alive exists the same way as this present moment. Now, there's another way to look at this idea that people who have sadly deceased do in some sense still exist. And it's because of the way that all the fundamental laws of nature that we know work. They don't destroy information. The only thing that they do is that they rearrange the matter and radiation and everything that's in the universe. They just give you the rules for how to put them in different places with different velocities.
All right, they don't destroy information, right, throughout the universe. And one of the basic laws of physics, if you call it, or preferred theory of physics, is that the laws apply throughout the universe equally. E equals mc squared applies everywhere. Whatever gravity is, it applies everywhere. It's the same. But if information is just being rearranged, much in the way, say, like you look at a log and then you set the log on fire, then it burns eventually and you no longer see it. And you say it doesn't exist. You say, well, it exists in another form, in all the vapors and in the smoke and stuff that dissipates. You can't see it, but the matter has just changed its form, but it is still, you could still call that a log, just in a different form. Now, information of the sort she's speaking of, where somebody dies and decays, but the one exception, I think, is black holes. That information can't come out of black holes. So if something falls into a black hole, something changes in that information. So, all right, let's see how she concludes.
You can apply those rules forward and backward. And this means if you had a really, really good computer, you can, in principle, always find out what happened earlier. So in this sense, information cannot get destroyed.
Right.
It can, however, become, for practical purposes, impossible to retrieve.
Yeah.
There are two cases that physicists have considered where information might get destroyed that have so far not been resolved. One of them is the information that falls into a black hole. We don't actually know what happens with it. And the other one is the mysterious measurement process in quantum mechanics, which is also an unresolved problem. So if someone you knew dies, then of course we all know that you can no longer communicate with this person. And that's because the information that made up their personality, it disperses into very subtle correlations in the remains of their body, which become entangled with all the particles around them. And slowly, slowly, they spread into radiation that disperses throughout the solar system and eventually throughout the entire universe.
I just heard the word solar. I was thinking that this is the argument that theologians would make for a soul, that the particles, if you would call it, are so small you don't see them, but they escape. And so I was thinking they called that the soul. And then she said solar system, and that was just a coincidence, of course. But that would be an argument, and it would be you can't refute it, you can't prove it, or even necessarily make it believable. You could just say, oh, the texts say that the soul or the spirit goes somewhere. But in some senses, they're not that different in the way they're being conceptualized. Very small particles leaving. Now, I don't know if theologians would say that a soul has any kind of corporeal nature to it. Just depends on which theologian you're speaking with. Could it be so small that there is some kind of actual life form and personality that stays intact, such that if your soul goes somewhere, if it goes somewhere such that your personality that you've got now remains intact, so you're recognizable in some form, however that would be, but there is a certain similarity between what she's saying about what happens, the way she's describing it, with particles just dissipating to such an extent that you can't communicate, can't see them, can't differentiate one from another. and you just go on with what you actually can see in life, those things that are directly in front of you and could cause you harm or benefit.
But this is a very anthropomorphic thing. It's very tied to our own existence.
Always.
And who knows what's going to happen in 1 billion years or something to the nature of humans. Maybe there'll be some cosmic consciousnesses which will also be spread out, and this information will become accessible again. So I know it sounds crazy, but for all we know about the fundamental laws of nature, about Einstein's theories, and about the way that our current theories work, it seems that our existence actually transcends the passage of time. There is something timeless about the information that makes up us and everything else in the universe. And I think that's a really deep spiritual insight that we get directly from studying the foundations of physics. And I have to admit that I personally find it really hard to make intuitive sense of it. It's one way to look at the maths and say, okay, this is how it works. These are the conclusions that we draw from our observations, and the mathematics describes it correctly. It's another thing entirely to make sense of this in your everyday life. But as a physicist, I trust the process of knowledge discovery that comes from using the scientific method, and so I take this seriously.
Love it. Love it. I like the way she presented it too, but this also, just to make a dovetail off of a point I made in the beginning about the title of the channel, as it stands now, which is Thinking Theology, which will be changed, that it is the product of thought. She's thinking about it. You could call it metaphysics, whatever you want, but there is thought involved with it. And she referred to, she used the word spiritual at one point, just sort of these things that are sort of outside the scientific method. And she thinks whatever is out there, that the physics, the math, the scientific method will lead to a conclusion of some sort, and it may not in her lifetime, of course, or mine, and if there, whatever, there's so much we don't understand, but we rely so heavily on our own acumen, our own abilities, and we rely something like 85% of what we glean, these are various estimates, but a very high percentage of what we glean as humans comes from our eyesight. And if we can't see grandma, or we can't see that fire log because it burned and it's up there, it doesn't exist. But her argument is that the information still exists somewhere. We just can't decipher it. Our eyes are one medium of information gathering, but there are so many others. Like the Hubble Space Telescope has its limited means of observing the universe. Then put the James Webb Space Telescope up there where it's able to see infrared and near cam and all this sort of stuff. It's able to go through a lot of the space dust, if you will, and B-mode polarity and the cosmic background radiation. It's able to see a lot of things that Hubble couldn't because it has different detectors on it. Now, down the road in 1 billion years, as she suggested, you could pick your amount of time. Will there be a record that the universe has kept? And will humans, if we're around in 1 billion years, I've got no reason to think we will, very little reason to think we will, but will we have the means of deciphering grandma? But in this case, grandma might still be alive somewhere. And certainly if you're on another planet, if grandma died last year, but you're on a planet surrounding a star that's 50 years away, eventually grandma, when she was younger, is even going to show up there. So I hope, hopefully grandma's an interesting person. All right, guys, this is fun stuff to contemplate. And leave your comments. I read them, and we'll go from there. Have a great day. See you on another video, and keep thinking.